I don't want to do this, but it is what it is. Today we're going to talk about one of my least favorite subjects in cybersecurity, and that is cross-site scripting. So yesterday we finished the SSRF room on the junior penetration tester path, and today we're going to go to the next one. I wish I could skip sections here, but I want to be thorough and go over with everything, even though there are some subjects and things that I don't like in cybersecurity and penetration testing, and cross-site scripting is one of them. Let's see if we have a certain machine that we need to start. Now, as always, I'm gonna try to wrap this video in about 20 to 25 minutes. If it doesn't go through, we're gonna have to leave it over or leak into a second part video. It's worth noting that because XSS is based on JavaScript, it would be helpful to have a basic understanding of the language. That's a very good start. However, none of the examples is overly complicated. Also, a basic understanding of client-server requests and responses. XSS is classified as an injection attack where malicious JavaScript gets injected into the web application with the intention of being executed by others. In this room, and not necessarily, in this room you learn about the different XSS types. Sometimes you can execute stuff on the server side. There are some situations where XSS can lead to command injection, from what I know, but don't quote me on that. So it is possible. Regardless, cross-site scripting vulnerabilities are extremely common, which is why I don't look for them. Below are a few reports of XSS found in massive applications. Therefore, you can get paid well for finding and reporting these vulnerabilities. Yeah, maybe for someone who's into bug bounties or actually getting themselves stressed out and maybe leading to a lot of duplicates on these public platforms. But in any case, I don't want to talk about bug bounties because I work in penetration testing, and the little amount of time I do in bug bounties is spent on Synac, most of it, or on private programs on other platforms. What does XSS stand for? So, do they have a like that? Alright, XSS payloads. The payload is the JavaScript code we wish to be executed on the target computer. So it's good to start with some basic notations, not only in XSS, but in every situation of attacking in cybersecurity or penetration testing. In situations where you need to attack something, you have a payload. There are two parts to the payload, the intention and the modification. Now this is interesting because I haven't thought of it as such. The intention is what you wish the JavaScript to actually do, which we'll cover with some examples below, and the modification is the changes to the code we need to make it execute, as every scenario is different. This is the simplest of payloads, where all you want to do is demonstrate that you can achieve XSS on a website by causing an alert box to pop up, which is your denoting or you're telling the server that this is a script, which is denoted by the closing, opening and closing tags, and the purpose of the script is to cause an alert or a pop-up box XSS, which says XSS. You could also do prompt, you could also do confirm. Session stealing. Details of a user session such as login tokens are often kept in cookies on the target machine. The below JavaScript takes targets as cookie. Base64 encodes the cookie to ensure successful transmission. So do know it says successful, not secured. And then post it to a website, if you know what I mean, under the hacker's control to be logged. Once the hacker has these cookies, they can take over the target session. So in this situation, the script tells the server to actually go to this web page and get the document cookie by BTOA. So BTOA takes a JavaScript string as a parameter. In this situation, the string is the document.cookie. The below code has, so there is another situation where we have a keylogger. This means that anything you type on the web page will be forwarded to a website under the attacker's control. Now this is damaging if the website the payload was installed on accepted user login or credit card details. So in this situation, whatever is on the document on the web page, on key press function E, so you're creating a function which actually goes to this website and logs the key that has been pressed. Business logic. This payload is a lot more specific than the above examples. This would be about calling a particular network resource or a JavaScript function. For example, imagine a JavaScript function for changing the user's email address. Now, in this situation, your payload could look like so. Do note that you can change a user email's address, and you could run everything. I mean, in this situation, the script, of course, is not displayed on the page. But for example, when user logs in, or when user signs up, you're actually changing or adding another field that also sends you their password. That might be a sort of like more complicated situation or scenario, but still it's possible. Now that the email address for the account has changed, the attacker might perform a reset password attack. Not only that, but also this is a situation where we're talking about account takeover. The next 4 tasks are going to cover the different types of XSS vulnerabilities. Great. All requiring slightly different attack payloads and user interactions. Which document property could contain the user's session token? One of them is the document.cookie. Z. Cookies? Not cookie? Interesting. Which JavaScript method is often used as a proof of concept? Alert. But you should better not use alert. Better use prompt or confirm. Better use confirm. So types of XSSs. Reflected XSS happens when the user supplied data in HTTP request is included in the web page source without any validation. So here's an example scenario, and let's see how do we stand when it comes to time. Plenty of time. A website where if you enter correct input, an error message is displayed. The content of the error message gets taken from the error parameter in the query string and is built directly into the source. So in this situation, the application doesn't check the content of the error parameter, which allows the attacker to insert malicious code. In this situation, so we can see that we have the error parameter. So it's a parameter and it has a value. Now in this situation, if this parameter is not sanitized or validated appropriately, and in this situation you might insert malicious code, such as a JavaScript code. Now the vulnerability can be used as per the scenario in the image below. So you start by sending a link to the victim that contains a malicious payload. Then the victim clicks the link and it's taken to the website that was embedded in the malicious payload. Then the link containing the attacker's script is executed on the website. So in this situation, the malicious payload contains a script that's taking the victim to the vulnerable website, and on the vulnerable website, that's where another script is executed. And finally, fourth, the data the attacker's script gathered is sent to them. So all of this logistics happens or is being built on the website controlled by the attacker, which is in the malicious payload. The data the attacker's script gathered is sent to them. They could steal the victim's cookie, which would allow the attacker to take over the victim's account. Potential impact. The attacker could send links to embed them into an iframe or another website containing JavaScript payload to potential victims, getting them to execute code on their browser, potentially revealing session or customer information. Now, I've seen a lot of scenarios in my pen tests where the session handling or the session is being handled by tokens, by JWT tokens, for example, which a lot of them are being used these days instead of just plain old cookies. Some of them don't even, I mean, a majority of the pen tests that I'm doing most recently, or that I have been doing most recently, did not even contain any trace of cookies for that matter. So once you get, or once you're able to control not only the cookie but the token of a certain user, that actually gives you control over their website. You might not actually, you could actually have visual control in the browser, but probably the best way to handle that sort of control, so to speak, if you would be an attacker or if you're pen testing something, is with a web proxy such as Burp Suite, for example. Once you've found some, so you'll need to test every possible point of entry. This includes parameters in the URL, as we've seen here. So parameters here, like the error parameter, URL file path. Also, so you're thoroughly checking the URL, and sometimes HTTP headers, although unlikely exploitable in practice. Yeah, I haven't seen that a lot. Once you've found some data which is being reflected in the web application, you'll then need to confirm that you can successfully run your JavaScript payload. So you must ensure that this is not a situation where you're dealing with self-XSS. Your payload will be dependent on whether the application, your code, is reflected. You'll learn more about this in blah blah blah. Where in an URL is a good place to start to test for reflected XSS? Where? In an URL. Parameter? I don't know. Parameters? Parameters. Interesting. Stored XSS. The XSS payload is stored on the web application in a database, for example, and then gets run when other users visit the site or web page. Now, this is a more critical situation than the reflected XSS one. A blog website that allows users to post comments. This is the ever most basic scenario of a stored XSS, because when you're able to inject XSS via a comment, that comment is usually added to a database. Unfortunately, these comments aren't checked for whether they contain JavaScript or filter out any malicious code. If we now post a comment containing JavaScript, this will be stored in the database, and every other user now visiting this article will have the JavaScript run in their browser. So, situation. Attacker inserts, better see it like that because it's a PNG, inserts malicious payload into the website's database through an XSS, through a comment. Now, for every visit to the website, the malicious script is activated. So let's say, for example, that an attacker actually an leaves a comment on a certain article, on a certain page, on a certain blog with an XSS payload. That XSS payload gets into the database, and then each subsequent visitor to that specific article is going to activate the malicious script, because the database containing the comment is actually going to serve the comment to the web page as the web page is being populated from the database. Now, the data the attackers, the script gathered, is sent to them. They could steal the victim's cookie, which would allow attackers to take over the victim's account. So, like I said, this is a more serious situation than the reflected XSS. Now, potential impact: the malicious JavaScript could redirect users to another website, such as a phishing website, steal the user's session cookie, or perform other website actions while acting as the visitor. Let's see how we are on time here. Alright, 4 more minutes. How to test for stored XSS. You'll need to test every possible point of entry where it seems data is stored and then shown back in the areas that other users have access to. So you'll need a little bit of intuition and experience to sort of like figure out where a stored XSS scenario might be possible. Comments on a blog, user profile information, website listings. Sometimes developers think limiting input values on the client side is good enough protection, so changing values to something the web application wouldn't be expecting is a good source of discovering stored XSS. For example, an age field that is expecting an integer from a drop-down menu, but instead you're actually using a proxy that allows you to modify the request. So the web browser wouldn't actually allow you to modify the request in such a way that because you're actually being limited to the drop down menu. But if you do it via a proxy, which allows you sort of like full control to the request, you can manually modify the integer into something else, such as a malicious payload. Once you've found some data which is being stored in the web application, you will then need to confirm that you can successfully, of course. So, proof of concept or go home. Or, better said, POC or GTFO. Alright, how are stored XSS payloads usually stored on a website? Database? I don't know. Right. Now another one, DOM-based XSS. So let's go through the DOM one and then leave the other ones for the second part of this video. DOM stands for Document Object Model and is a programming interface for HTML and XML documents. It represents the page so that the programs can change the document structure, style, and content. A web page is a document, and this document, of course, so as you've seen above or someplace over here, XSS payloads, you can see the document being referenced here. Document on key press. So they're talking about the entire page. Now DOM stands for Document Object Model, and like I said, it represents the page so that the programs can change the document structure, style, and content. A web page is a document, and this document can either be displayed in the browser or as the HTML source, like right-click, view source. A diagram of the HTML DOM is displayed below. So you have the document, root element, document.root, which is the HTML, opening tags and closing tags. Then you have head and body. The header contains these elements. The body contains whatever other elements they're talking about. So if you want to learn more about the DOM and gain a deeper understanding, go to we3w3.org, web3. Alright, exploiting the DOM. DOM-based XSS is where the JavaScript execution happens directly in the browser without any pages being loaded or data submitted to the backend code. So everything happens in the browser. Execution occurs when the website JavaScript code acts on input or user interaction. Example scenario. So the website's JavaScript gets the contents from window location.hash parameter and then writes that onto the page in the currently being viewed section. The contents of the hash aren't checked for malicious code, allowing an attacker to inject JavaScript of their choosing onto the page. Potential impact: crafted links could be sent to potential victims, redirecting them to another website, or stealing content from the page or the user session. How do you test for it? Everybody says that it's challenging to test for DOM-based XSS and requires a certain amount of knowledge of JavaScript to read the source code. So that's why not only I don't study JavaScript to actually be able to spot DOM-based XSS, but I study JavaScript to be able to do decent source code review. So in this case, if you need a motivation to actually get started with source code review, if you're motivated by finding banal XSSs, be my guest and learn JavaScript. You'd need to look for parts of the code that access certain variables that an attacker can have control over, such as window.location.x parameters. When you found those bits of code, you then need to see how they are handled and whether or not the values are ever written to the web page. So it's not only that those variables, such as this one, exist, but whether or not they are ever written to the web page. Of course, what would be the utility of actually having a certain variable if you don't use it? But there might be variables that aren't displayed or rendered to the web page, which is why this statement makes sense. To the web page's DOM or passed to unsafe JavaScript methods such as eval. You can think of evil as evil. And you can also look for eval when you're testing or when you're doing source code review. What unsafe JavaScript method is good to look for in source code? Eval. Doesn't take a wizard to figure that one out. So we got the first 5 tasks. 6, we have blind XSS, perfecting your payload, machine is already started but hasn't been used, and the last one, practical example. There's another machine in here, that's interesting. Alright, but for the sake of time, I will stop this video here and move on with the following tasks in the subsequent one.